So far we have studied the different components that are present in the computer. Now we are going to see the interconnection between these components. So we have these components CPU, memory and input-output model. Now let's see what kind of information or information flows are present inside a computer. First of all, we know that there is a data flow from the memory to ALU. For performing different operations, the data present in the memory should be given to the ALU. Then the after data is processed, the data is kept back in the memory. So this is the one data flow that is present in the system. The another is from the memory to input output devices. So the memory can be read, and from the input devices the appropriate locations can be written at the memory. Then we need to know that the memory can be accessed only if the particular address is given to it. This address is provided by the control unit or the CPU itself. So there is an address line that connects the CPU and the memory. The address is also present for the input output devices if there are multiple ports present at the input output. So the address is given to each input output has unique address, and that is given by this address line. And finally we have the control unit. It is giving control signals to all the other devices, such as we have these control signals given to the ALU. Then we have control signals to the memory as well, and also to the input output devices. So these are the three different kinds of signals are present. The green one is data, which is data transfer operations. The pink ones are the address lines, which provides the address, and the blue ones are control lines, so control signals. So these three kinds of signals are present inside a system. Now let's look at the more appropriate configuration of this system. So this is the another representation of the bus structure that is present in the computer. We have CPU, memory, input and output devices. So this is nothing but a system bus structure. It consists of control, address and data bus. So each unit is individually connected to each bus. The connection can be bidirectional or unidirectional depending on the functional unit and its function. For example, the address lines are for memory and input output devices is always going to be unidirectional. Okay, so because the address is only given to that unit. Okay, now let's look at the further module. So this is the representation single bus CPU architecture, in which the single system bus is present and it connects all the components together. So note here that at a time only one kind of information can be present on the system bus. So only two devices can communicate with each other at a particular time. So this is the single bus structure, and it has a single data transfer at a time. In this structure, the major advantage is that this system is much simpler to operate as well as to construct or design. However, there is a drawback that the input-output devices are generally much slower and used much less frequently than that of CPU and memory. So the communication or the signals between input-output devices often interfere the normal operation between CPU and memory, which is, since the memory is accessed a lot of times, there has to be, it is desirable to have a separate different bus for the memory and different bus for the input-output devices. So with this we can we come up with the concept of multiple bus hierarchies or multiple bus structure. Now let's look at that. So this is the multiple bus structure that is present. So from the system bus, CPU and memory are connected, and the data flow between the two of them is virtually uninterrupted. And we have the secondary bus that is called IO bus, to which input-output devices are connected. Now to provide the interface between the CPU and input-output devices, we have some unit called bus controller. This bus controller provides the necessary interface between the system bus and the input-output bus. So we can see here that all the time the operation between CPU and memory is carried out through the system bus. Whenever input or output devices wants to communicate with CPU, it has to communicate it through the bus controller. So this is the structure and functioning of multiple bus structure. This kind of hierarchy is commonly used in the many processors. So we have learned about the bus structure, the need of bus, different bus data control and address bus present in the system, and different hierarchies that are available to us. I hope you have understood the part, and stay tuned for more lectures.